Hello everyone, welcome to the e-learning series. I am Dr. M.K. Deore. Friends, today I am going to start the fifth chapter, characteristics of the laser. Now in this chapter, we are going to see the different characteristics of the laser, such as the directionality, the monochromatic, the intensity and the coherence. Friends, in this lecture, we are going to see only the three characteristics. The first one is the directionality, the second one is the monochromatic, and third one is the intensity. Friends, in the first chapter we have studied about what do you mean by the laser and the comparison of the laser with the ordinary light source. We know that the word laser is the acronym of the light amplification by stimulated emission of the radiation. We also know that the laser is electronic device that emits the narrow beam of electromagnetic radiations. Now, but laser light is different from the conventional light sources because laser have some properties which are not found in a traditional light sources such as the sun, electric bulb and the incandescent lamp. The laser light has the four unique characteristics that differentiate it from the ordinary sources of the light. Now these characteristics are the directionality. The laser beam is highly directional. The monochromatic. The light emitted from the source of the laser are monochromatic. The third one is the coherence. Fourth one is the intensity. The laser beam is highly intense. Friends, we are going to see in details about the first characteristics, directionality. We know that in conventional light sources such as the lamp, sodium lamp or the torch light, photons will travel in random directions. Therefore, these light sources emit the light in all directions. Now see here in this figure. Now this is the ordinary light bulb and we can see that the radiation emitted from this bulb are all in different directions, that is the random directions. Now suppose if we consider here this is the torch light, then the radiation emitted from this torch light are also in a different directions. That means they are not in a same directions. But in case of the laser, all photons will travel in the same directions. Therefore, the laser emits the light only in one direction. And due to that, this is called the directionality of a laser light. Now see here, this is the laser source, it emits the laser light. We can see here, the all photons are emitted in a same directions. And due to that, it is called the directionality of a laser light. The width of the laser beam is extremely narrow and hence a laser beam can travel to a long distance without spreading. Now in this figure we can see here, the all photons are emitted in a same direction and due to that the width of the beam is extremely narrow. So the light emitted from the laser source is a very narrow beam of a source, and due to that the laser beam can travel to a long distance without spreading. The directionality is one of the most striking characteristics of the laser, and this property, due to this property, laser having the many industrial applications. The directionality of a laser beam is expressed in terms of a divergence. We have seen that the beam emitted from the laser source is a very narrow beam of the light. It is due to that the laser light has a very small divergence, and hence it is highly directional. The beam divergence of the laser near the source is almost zero, but the laser beam shows a little, that is negligible divergence after it travels at a certain considerable distance from the source. Now see here, in this figure we can see that near to the source, the radiation emitted from the laser source, the all lights are travel in the same directions, and the divergence of the beam is almost zero. But the distance from the laser source over which the light remains parallel is known as the relay range, and that range, the relay range, is shown in this figure here. Beyond or after this range, there will be a smaller divergence we can observe in a laser beam. So now in this figure we can observe here, after this relay range there is the some divergence. Now then we can obtain the expression for the divergence here. The laser is so little divergence beyond the relay range because of the diffraction phenomenon. There are the two parameters which causes the divergence. The one is the size of the beam, and second is the diffraction. Students, in SY.B.Sc you have already studied about the diffraction. That is, the bending of the light towards the edge of an obstacle is known as the diffraction. So beyond the relay range there may be some diffraction, and due to that there is the divergence. And the first one is the size of that the beam. Now see here, twice the angle of the divergence is a full angle beam divergence. That gives how much the beam will be spread as it travels through the space. Now see here, theta is the angle of the divergence. Now here we can see that the twice the angle of the divergence, that means the 2 theta, is full angle beam divergence. So the 2 theta is the full angle beam divergence, and that gives how much the beam will be spread as it travels through the space. The full angle divergence is given by, now see here, according to the geometry of this figure. Now we can write here the full angle divergence, the 2 theta, it is equal to be the 4 lambda divided by the pi d. Now here d is the diameter of the laser beam. Lambda is the wavelength of the light. The beam divergence due to the diffraction is determined from the relay range, that is the angle of divergence theta, it is equal to be the 1.22 into lambda divided by the d. Now here d is the beam diameter of the laser beam at a distance L from the laser source. Now see here, this d is the beam diameter, and this beam diameter is measured at a distance L from the source here. Now from this figure we can write here, that is from the geometry of this figure we can write the tan theta, it is equal to the L R divided by capital L. Now here R is the radius, then we can write it in terms of the diameter. Therefore the tan theta, it is equal to the twice R divided by the twice L, that is by multiplying and dividing by 2. So we can write the tan theta, it is equal to be the capital D divided by the twice L. Now where D is the beam diameter of the laser beam at a distance L from the laser source. Now but we know that the theta is very small, then we can write the tan theta, it is equal to the theta. Therefore the beam divergence, that is theta, it is equal to be capital D, that is diameter divided by the twice L. Now here the theta is the angle between the center of the laser beam and edge of the laser beam, and this angle theta is known as the divergence angle. The laser beam carry the energy and the data to a very long distance for a remote diagnosis and the communication purpose. That is due to that very small divergence of the very small beam divergence, the laser beam carry the energy and the data to a very long distance for the applications such as the remote diagnosis and the communication purposes. So the friends, you have to remember here, what do you mean by the directionality, what do you mean by the divergence, and how we can obtain the expression of the beam divergence. Now consider a light of the wavelength say as the lambda, it is equal to be the 1.06 into 10 raised to minus 3 nanometer. The diameter of the beam is the 2 millimeter. Now then by using the formula theta, it is equal to be the 1.22 into lambda divided by the d. So by substituting these values, the divergence angle, it is equal to be 0.5831 into 10 raised to minus 3 radians. If we convert it into the degree, so the divergence angle, it is equal to be the 0.033 in degrees. So we can see here the divergence angle in case of the laser beam is very small. But if we take the example such as a searchlight, then its divergence angle is lies in between 8 to the 10 degree, while a normal flashlight has a divergence angle lies in between the 20 to the 30 degree. Therefore, if we consider these two examples, now then we can say that the divergence angle in case of the laser beam is very small or it is negligible. So remember that the divergence angle in case of the laser beam is very small. Now friends, we are going to take the second characteristics, that is the monochromatic. We know that the monochromatic light means a light containing a single color or the single wavelength. That light is known as those light having the single wavelength. Now then we can say that light is the monochromatic light. We know that The photons emitted from the ordinary light sources have the different energies, frequencies, the wavelength and the colors. Now the light waves of the ordinary light sources have the many wavelengths or the colors. Therefore, we can say that the ordinary light is a mixture of the waves having the different frequencies of the wavelength. Now see here, if we pass the white light through the glass prism, then we observed a spectrum of the different colors ranging from red to the violet, and these colors having the different wavelength. Therefore, we can say that the ordinary white light is a polychromatic. But now in case of the laser, that is on the other hand, in laser all emitted photons have the same energy, frequency or the wavelength. Hence, the light waves of the laser have the single wavelength or the color. Therefore, the laser light cover a very narrow range of the frequency or the wavelength. Now see here, if we pass the laser beam through a glass prism, now then we observe that after passing the laser beam through the glass prism, then it emits again a single color of the beam. So we can, from that we can say that the emitted beam from the glass prism is a single color and having a single wavelength. So we can say that a laser light is a monochromatic. Now in practice, no source of the light can emit the monochromatic light. That is light of the single wavelength or the color. In a previous chapter, we have seen that laser light is also not exactly monochromatic. That means it consists of some spectral lines. That means, now see here in this figure we can see that the beam of the light consists of a small spectral lines having a small difference in the wavelength of the frequencies. The light emitted by the ordinary source of the light has a wide range of the wavelength or the frequency, we can say that the bandwidth. But however, the laser light has a smaller range of the wavelength or the frequency, and due to that it having a very small bandwidth. The bandwidth of the ordinary source of the light is about 10 raised to 10 Hz, but the bandwidth of the good quality laser is about only the 100 Hz. Now see here, in this graph we can see that this is the plot of a graph of the intensity and the frequency. Now then we can observe here that, now see here, this is the graph, this is the curve for the light, for the ordinary source of the light having the frequency say as the nu1 and the nu2. Now while this graph or this curve is for the light source from the laser source, this is the light from the laser source, and we can see here it having the very small bandwidth lies in the frequency, in the two different frequencies nu1 dash and the nu2 dash. The light emitted by the ordinary source of the light spread over the wide frequency range and it is given by, or it is called, the bandwidth. And in case of that, the ordinary source of the light, the bandwidth is given by the difference between the two frequencies, that is the del nu, it is equal to the nu 2 minus nu 1, which is around the central frequency nu 0. However, the light emitted by the laser source spread over a very small frequency range, and that having the bandwidth say as the del nu dash, which is the difference between the two frequencies, that is nu 2 dash minus nu 1 dash, and which is around the central frequency nu 0. So from this graph we can see here the bandwidth in case of that the ordinary light is large as compared to the light emitted from the laser source. The third characteristics of the laser beam is the intensity. The intensity of the laser beam is defined as the energy per unit time per unit area placed at right angles to the direction of the propagation of the wave. Now see here, this is the laser beam. Now the laser beam is incident on the plate here or on this surface area. Therefore, the intensity of the laser beam is, we can define here, the energy per unit time per unit area placed at right angles to the direction of the propagation of the wave. The intensity of the laser beam can also be defined in terms of the power. That is, the intensity of the laser beam is defined as the power of the beam per unit cross-sectional area of the beam. The power is nothing but the energy per unit time. Therefore, the intensity, it is equal to B, the energy per unit time per unit area, and that is equal to be the power per unit area. We can measure the power in watt and the area in meter square. Therefore, the unit of the intensity is watt per meter square. The intensity of the laser beam is a measure of the amount of the energy that can be applied to a specific region within a given amount of that time. That means here the intensity of the laser beam now is a measure of the amount of the energy. Now see here, this is the source of the laser and it emits the beam of a laser. Now when it incident on this surface area, then the intensity of this laser beam is a measure of the amount of the energy that can be applied to a specific region within a given amount of that time. So remember about the definition of the intensity, how we can define the intensity, what is the unit of the intensity. The power output of the laser may be vary from few milliwatt to the few kilowatts, and due to this varying intensity, the laser having the number of applications from industries to the medical applications also. But this energy concentrated in a beam is a very small cross section. Now since the laser gives out the light into a narrow beam and the light energy is concentrated in a region of small area, therefore the intensity of the laser beam is very high. Now in the previous two characteristics we have seen that the laser beam having a very small divergence, and due to that it carries energy for a long distance. Hence the laser gives out the light into the narrow beam and the light energy is concentrated in a small area. Therefore, the intensity of the laser beam is very high. So remember here, due to the highly directional, it produces the highly intense beam of a laser. The intensity of the laser beam is approximately given by the I, it is equal to the 10 square divided by the lambda square into the P. Now here P is the power radiated by the laser. So remember, we can express the intensity of the laser beam in terms of the power and the wavelength. That is I, it is equal to the 10 square into the P divided by the lambda square. In laser, the light is spread in a small region of the space and a small wavelength range. Hence, the laser light has a greater intensity as compared to the ordinary light. If we look directly along the beam from a laser, then all the power in the laser would enter your eye. Thus, even a 1 milliwatt laser would appear the many thousand times more intense than the 100 watt ordinary lamp. So generally, we take care we never see directly to the laser beam because the laser beam is highly intense and the high power, and due to that all the power in the laser will enter your eye and the laser beam will damage your eye. Now see here, the intensity of the laser beam at the room temperature. Now we can see here the intensity, it is equal to be the 2.5 into 10 raised to 11 watt per meter square. Now if we consider here the 1 milliwatt of the laser here. Now but to obtain the same intensity from a tungsten bulb, it will rise to a temperature of 4 into 10 raised to 6 degree Kelvin. But we know that the normal operating temperature of the bulb is about 2000 degree Kelvin. Now see here, if we use the 1 milliwatt of the laser at a room temperature, then it produces the intensity or the intensity of that the beam will be the 2.5 into 10 raised to 11 watt per meter square. Now see here the power is 10 raised to 11. That is the intensity of the laser beam at the room temperature is very high. But if you want to obtain the same intensity from tungsten bulb, then you have to be, then it will rises the temperature. If to obtain the such intensity of the radiation from the tungsten bulb, then the temperature will be the rises 4 into 10 raised to 6 degree Kelvin. This is very high because the normal operating temperature is about 2000 degree Kelvin, and hence it is impossible or practically it is very difficult to operate the tungsten bulb at this very high temperature. So we can compare the intensity of the any laser source and the any ordinary source of the light. Therefore, the laser due to its very high intensity is widely used for cutting and the welding of the metals and the alloys. So the student, you have to remember that due to these three properties, properties are very important because by considering three properties, the laser having the number of applications from domestic to the laboratory or in a medical field to the industrial applications only because due to these characteristics of the laser. Now we are going to take the example depending on the characteristics of the laser. Now take the first example. Calculate the intensity of the helium neon laser beam having the emissive power 1 milliwatt and the wavelength 6328 into 10 raised to minus 9 meter, and the intensity of the ruby having the emissive power 5 milliwatt and the wavelength 6928 into 10 raised to minus 10 meter. So the student, you have to be calculate the intensity. So first write down the given quantities here. You have given the wavelength and the power. The first wavelength is the 6328 into 10 to the minus 10 meter and its power is 1 milliwatt. While the second wavelength is 6928 into 10 to the minus 10 meter having the power 5 milliwatt. Therefore, by using the formula of the intensity, I it is equal to be the 10 raised to 10 square divided by the lambda square into the P. So by substituting these values, we can calculate the intensity. So for the 1 milliwatt laser, the intensity, we get the intensity the 2.5 into 10 is to 11 watt per meter square, and for the 5 milliwatt laser, the intensity, we get the intensity 10.37 into 10 is to 11 watt per meter square. Students, now in this lecture, I have taken the three different characteristics of the laser, such as the directionality, the monochromatic, and the intensity. And the one of the problem based on the intensity. So remember about in details these three characteristics of the laser and how to solve the problem related to the intensity. Thank you.